Hello everyone, in this video I will talk about the change in momentum. The change in momentum is defined by delta P, this is the change, delta P is always equal final momentum minus initial momentum, P initial. So if I have an object with mass M moving with a velocity v, this is initial velocity, to the right, this object, for example, this is a wall, the object with mass m and velocity, initial velocity, will bounces off the wall and then return to the left. This is the final situation. The mass m will return to the left with a final velocity. So it bounces the wall. After that, it will be returned to the left. So what is the initial velocity? It's vi, for example, I have vi equal 3 meters per second. The mass is 200 grams. So the initial velocity, the initial momentum, pi, initial, is simply equal m multiplied by vi. And m must be with kilogram in SI system. So I have to convert the 200 gram to 0.2 gram. So multiplied by 3, I obtain 0.6 kilogram meter per second. This is the initial momentum. And the direction is rightwards, to the right, to the right. Now, if I want to calculate the final momentum, so here I can represent the initial momentum. As I said in my previous video, always the momentum is with the velocity. So P and V have the same direction because the mass is positive. And in the final state, here the final state, the momentum is oriented to the left, PF. So after finding this value, 0.6 kilogram meter per second, I can say to the right, because initially the PI is oriented towards the wall. After it bounces the wall, it will return to the left. So now I will calculate the value of the final momentum. P final is equal m, the same mass, multiplied by V final. So it's equal, suppose here the V final, the final velocity is 1 meter per second. So it becomes the mass 200 grams, 0.2 kilogram multiplied by 1, and I obtain 0.2 kilogram meter per second. To the left, it's oriented to the left. Okay, now to calculate the delta P, the change in momentum, I have to select a direction, an arbitrary direction. And all momentum with my direction are considered as positive, and opposite to my direction, the momentum will be considered as negative. So if I will consider this direction, arbitrary direction, this is the positive direction here. Now I will calculate the variation of the momentum, delta P equal P final. Always delta P is final minus initial. Delta, the change of any physical quantity is always the value of this quantity, the final value minus the initial value. So here in the momentum, it's the same. Always P final minus P initial. So here, the final momentum is directed to the left, so it's opposite to my choice, my arbitrary choice of direction. I make a choice that the positive is to the right. However, the final momentum is to the left. So I take this value and I will add a minus 0.2 minus, and the initial is with the directions, so I will keep this value positive, minus 0.6, and the result is minus 0.8 kilogram meter per second. Okay, also I can say that the delta P is 0.8 kilogram meter per second, but this minus, I can express it here. What does mean minus? Minus is opposite to this direction, so to the left. I add here leftwards, leftwards or to the left. So here, pay attention when you calculate the change in the momentum. The change is always the final minus initial. Before make the calculation, you have to make this a choice, positive direction. No problem if you change to the left or to the right, but when you make a choice like this to the right, the positive direction, if the momentum is with this choice, this direction, the momentum is positive. If the momentum is directed in the opposite direction, so you have to add a minus, and you make the difference. Here I find it minus 0.8 kilogram meter per second. I say delta P 0.8 kilogram meter per second, but this minus means that the delta P, the change is contrary to this direction, so is leftwards or to the left. Thank you very much.